Okay, so today I am teaching Danny mesh analysis. I did nodal in a different video, and I'll link that video to this one in the description. But here's for mesh analysis. It's very similar to nodal analysis. And so this is the equation that we're going to be using for this video. And so let me break it down for you. The self-resistance multiplied by, in nodal analysis, we analyze nodes. In mesh analysis, we analyze meshes. So instead of being nodes, these are meshes, right? So the current of the resistance of itself when you analyze a mesh times that mesh minus the summation of the mutual resistance times the other currents, or the meshes, right, is equivalent to the sum of all the voltages. And so this will make a lot more sense when I actually do it. But we're going to analyze the green mesh first, I1. So the self-resistance is 3, 4, and 5. All right, times the mesh that we're talking about, right, minus the mutual meshes.
Should be 5. 5 and 4.
Right, so 4 times I3, right, minus 5 times I2. And that's going to equal the sum of the voltages. So it doesn't matter which one's positive, which one's negative, as long as you are consistent.
Okay.
And so if we're gonna say that when it goes from a negative to a positive, we're gonna divide it as positive, and when it goes from a positive to a negative, we're gonna define it as negative. So this one goes from a negative to a positive, so that's a positive 150 volts, right? This one goes from positive to a negative, so it's negative 100 volts. And this one goes from positive to a negative, so it's negative 74 volts. And so that is our first equation. We got 3 unknowns, so we need 2 more equations. We'll analyze this one next.
I do.
Yep, the red one. So the self-resistors are
6 plus 5.
right, 6 and 5 times I2 minus the mutual. 5 is I1. And
6 is with I3.
6 is I3. And that's going to be equivalent to the voltages, right? So this is positive 74, positive 15, positive 23.
Yeah.
And now for the blue one. Its self-resistance is
8, 4, and 6.
4, 8, and 6. Times I3 minus positive 100, negative 191, and negative 15.
Yeah.
Negative 191, negative 15.
Making a video for circuits.
And
You're a step ahead of yourself. Those
I'm
are the
way ahead of
voltages.
myself.
Yeah.
The mutual, right? That's the next step. So the mutual with I1 is 4. So 4 times I1, right?
Yeah.
So the mutual with I2 is 6.
When you have 2 variables like
6
this,
times
eight,
I2.
you have to make it in terms of one.
Is equal to what you had on the left side originally.
Correct.
The
Yep.
voltages.
So positive 100,
Eight
negative 191,
in terms of
And positive 15.
and
all the
negative
Negative.
15.
Yeah.
Alright, so I'm gonna move all this stuff over there and simplify it down.
Yeah.
Okay, so originally in the video we forgot to add a value for a resistor, which is not good. So this is 8 ohms. Right, that resistor we didn't add a value at the beginning, and it's 8 ohms, and that only changes a little bit. Thankfully, it goes right here. It's not a neutral. It's just a self with I2. So that is 5 and 6, right? 5 and 6 and 8. Okay, so what I did here was I just rewrote this big equation right here. I rewrote this big equation right here. And I rewrote this big equation right here. So we can better understand it. I'm also going to put a link to a video on how to solve a system of equations on a TI-84 Plus CE in the description. And that's how you would solve something, a system of equations like this. And when you plug that into your calculator, you're going to end up with I1 as -2 amps, I2 as 4 amps, and I3 as -5 amps. So yeah, that's mesh analysis.